In this video, we will answer the question, why is the derivative of the volume of a sphere equal to the surface area of a sphere, where the volume equals 4/3 pi r cubed and the surface area equals 4 pi r squared. Given the volume of a sphere, v equals 4/3 pi r cubed, let's begin by determining dv dr, or v prime of r. To do this, we apply the power rule of differentiation, and therefore the derivative is equal to 4/3 pi times the derivative of r cubed with respect to r, which gives us 4/3 pi times 3r squared. Simplifying, we have dv dr, or v prime of r, equals 4 pi r squared. And 4 pi r squared is equal to the surface area of a sphere. So the question is, why is the derivative of the volume equal to the surface area? To begin, let's review some notation, where differential v or dv describes the change in the volume, differential r or dr describes the change in the radius, and therefore dv dr, or v prime of r, describes the change in the volume with respect to the radius. And now, beginning with a sphere with radius r, let's consider a small increase in the radius. And let's let that small increase be differential r as shown here. Notice how differential r, or the change in the radius, produces a small increase in the volume, which should be the volume of the shell or extra layer created when the radius is increased by differential r. And therefore, if we can determine the volume of this layer or shell, we can determine differential v, the change in the volume, given a small change in the radius. So if we flatten this shell or layer created by the increase in the radius, it will produce a right circular cylinder as shown here. Let's look at some additional images. Let's let a ball filled with air represent the shell or layer we want to find the volume of. As we begin to squish the ball, it might look something like this. Once it's completely flattened, it will look like this, which will be a right circular cylinder, where the top is a circle, the bottom is a circle, and the height or thickness is going to be 2 times differential r, where again differential r represents the change in the radius. So we need to find the volume of this right circular cylinder. To find the volume, we need to find the area of the base and multiply it by the height. And now to find the area of the base, we know it's a circle, but the area is going to be equal to half of the surface area of the sphere, because if we take a look at this picture here, we can see as we begin to flatten the ball, the top and the bottom will be a circle, and both circles are formed by the total surface area, and therefore half the surface area will give us the area of the base. And therefore the area of the base is equal to 4 pi r squared divided by 2, where 4 pi r squared is the surface area. And therefore the area of the base is 2 pi r squared, and the height is 2 differential r. So going back to our previous slide, the volume of this right circular cylinder, which represents the change in the volume, is equal to 2 pi r squared times 2 differential r, which again represents the change in the volume, and therefore we can say that differential v, or dv, equals 4 pi r squared times differential r. And now if we divide both sides by differential r, we have dv dr, or v prime of r, equals 4 pi r squared, which is the surface area of a sphere. So the derivative of the volume of a sphere is the surface area. Increasing the radius will result in an increase in volume proportional to the surface area. I hope you found this informal discussion helpful to explain why the derivative of the volume of a sphere equals the surface area of a sphere. Thank you for watching.